Hey everyone, welcome back to the Master App series. In this video, we will set up the SQLite database and create the models for users, subjects, chapters, quizzes, questions, scores. By the end, you will learn how to set up the database schema and create the models. So let's dive in. Okay. So the first concept we will see is ORM. So what is ORM? So ORM basically stands for Object Relational Mapper. And what it does, it just maps your database tables into objects in your programming language. It also defines a relation between the objects. So with the ORM, you don't need to write SQL queries because SQL queries might be error prone, but that's not the subject. The ORM basically provides a lot of advantage over the raw SQL queries. Like with the ORM, the query is easy, and you have to interact with objects only, not directly with the database. So you write code to interact with the object that translates into SQL queries by the ORM, and it just gives you flexibility to use the databases like any databases which ORM supports. So you don't need to modify your queries based on the databases. You only write once, and it just runs on all the databases supported by the ORM. So that is the first. The second is the syntax is easy to interact with the object rather than writing the SQL queries. So lot of benefits you have, and when you have object, you can apply multiple terminologies based on your programming language. So you can have full access to the object. If your programming language is object oriented, then you can have a lot of advantage over that. So in this project, we are going to use one ORM, that is SQLAlchemy, and we will be using Flask-SQLAlchemy. That is the wrapper of that is the extension or wrapper for SQLAlchemy. So we will install this ORM first using the pip install, and first check you have activated your virtual environment. So let's deactivate and activate again for you guys. Source.pnb bean activate, and then install the ORM, install Flask SQL Alchemy. Install it. We have successfully installed the Flask SQL Alchemy. And now let's update our Flask app to use the SQLite. Okay, let's do that. I have been using one extension, if the Python. So if you are using the VS Code, you can install this. This will help you to write the code, like it will help you write the Python codes. Okay, so in our init file, we will import the module from Flask SQL Alchemy. So import the SQL Alchemy module, and then initiate our database first, and then we have to configure the database with application. So for that, we have to override the predefined environment variable that you have to uh, like you have to supply some values so you can interact with your application. So the first will be the main is SQLAlchemy database URI, that will tell where is your database file. Okay, so I want this file as quizmaster.db, and then we will disable the tracking SQLAlchemy, and that is totally optional. False. Okay. And then we will connect our database with the application using db init app and then supply the app. So now with this command we'll connect the app with the database, and after that we are returning the Flask application, Flask instance configured with the database. So we are done here. Next we will start creating the models. Okay, so for that, first we will visualize our database. Okay, so I made some ER diagram, entity relation diagram for the database that we are going to create. So let's take a look on this, what we are going to do and how many entities are there. So we will have uh, this many entities, like the first one is user, and then we will have the subject, then the chapter, then the quiz and the question and score. So user will have ID as integer, then the username, the password, the full name, qualification, and date of birth. Then the subject have the ID as primary key, then the name and description. And the chapter have also the ID, name of the chapter, description of the chapter, and the subject ID. So it can relate with the subject, as like the subject ID will be the foreign key. So with that, chapter can connect with the subject. So you can then have the relation like subject have many chapters, or chapter has one subject. Okay, and similarly we will have the quizzes. um, so the chapter has the quizzes, and quiz will have the ID, date of quiz, time duration of the quiz, and chapter ID as foreign key to connect with the chapter, or it tells like which chapter it belongs. Okay, then we will have also the question. So quiz will have the questions, and question have uh, multiple fields like the ID, the primary key, the question statement. Then we will have the answers, option 1, option 2, option 3, option 4, and there will be one correct option. So while calculating the score, we can compare which is the correct one, and based on that we'll create the score. And then we will have the quiz ID as foreign key here to connect, like to belong with the quiz. Okay, and at last we'll have the score table. So the score entity uh, will be based on the user and quiz. So um, it will have the ID, the primary key, then the total scored, like how much the user scored, and the timestamp when it has been submitted, and then the user ID as foreign key and quiz ID as foreign key. It tells the score is connected with two tables. It connects with the user and also the quiz. So basically it telling the scored record will tell like which quiz it belongs to, and uh, like which user submitted the quiz. uh, so the result is score. Okay, so that's why it must have two connection, the user and quiz. So user will have many scores for many quizzes. Okay, so user can be part of different quizzes, and then the user will have different multiple scores that relate with specific quizzes. Okay, okay, That is the ER diagram for our database. And you can also see the database schema diagram here. So we can tell like the score must have only one user and must have only one quiz. A user can have 0 or many scores. Quiz can have 0 or many scores. Subject can have 0 or many chapters, but chapter must have only one subject. Similarly, chapter will have 0 or many quizzes, but quiz must have only one chapter, and so on with the question. Okay, so let's start creating our models. So the first model will create the user model. Okay, so let's start creating with the user model first. For that, first have to create our models.py file. Okay, then start importing db from app, and then start creating a user model. So when we initiate the db with the SQLAlchemy module, it gives you two options. The first is db model. With that, we create a, a model object, and that maps to the table. Like it will translate the object into table, so it will translate to user table. Okay, then it gives one more, the session function, that helps to uh, query the database. Okay, we'll use next. So first create the model with db.model and start creating our fields. So the first field is id, and the id column will have the type of integer, and it will be a primary key to connect with the references. Okay, the next is username, password, full name, qualification, and dob. So all will be string. The dob will be date type of a field. So let's create username, password, full name, and qualification. The username column um, will be of string type, and the character limit can be 80, and this will be unique also. And the nullable false, that tells it must have some value when we create. Then the password, similarly the d password column will have the type of string, and the password could be hashed, so I think giving 200 character limit will be fine. And this also must be nullable false, so it must have some value. Then there is a full name, and full name column will be the type of string, and the limit will be 100, and the neighbor variable is false, so it must have some values too. Then after full name we have the qualification, and the qualification column will be also the type of string, and we can leave it as null, not mandatory or not required. Then we have the dob, and dob column will have the type of date. Okay, then we have also uh, the relation with the school. So the user can have many scores. So how we define this relation? So scores will be So user will have the relationship with score, and um, then it also have the backref with the user table. So it tells uh, that, or it helps score, like if you have the score record and you want to get the user record, so if you have added this option backref user, so score can get the user. Okay, if you haven't used this one, so user can have the scores, but score cannot fetch the user record for you. Okay, then we have the next option, the last option is lazy, and that the value will be true because we don't want to fetch all the records, like if we don't need that, like we are querying for the user and it must not load all the scores. So that's why we'll supply the lazy as true. So if we needed only, we can fetch these scores, otherwise just it is not needed. Okay, so with that our user model has been completed, and next we will add other models too similarly. Okay, so let's create other models also one by one. So first we'll start with the subject model. Okay, so class subject db.model, and the subject will have the id, name and description field. The id will be the similar, the id column will be the similar integer and the primary key. And then we have the name, the subject name. Subject name must be the string value, so it must be, I think the character limit for string is 100 enough for the subject, and it must have some values also. Then the description is text. So yeah, we have to add some description for this column. So this column must be of type text, cause might be we have lot of data to enter here. Okay, so we are done with the subject model, and we have a relationship also, so we have to also define the relation with the subject. So the relation will be chapter, so subject can have multiple chapters. So, and chapters relation will be like uh, with the chapter model, subject will have the relationship with the chapter model, and backref will be subject, so it can fetch the subject too, and here the lazy equal to true. So the subject will not load the chapters if we don't need that. Okay, similarly we will create the now the chapter as we have defined here. The chapter model we have to create, and the chapter model will have the values of id, name, description and subject id as foreign key. So id name will be the same, so id will have the integer type and primary key will be true. The name, the chapter name we have to store, so the character limit is 100 and it must have some value. Then we have the description, so description also might could be of text type, because we can have lot of data that we cannot store in the string. And then we will have a special relation or a special column, that is the subject id. That column will have the type of integer, but it interact with our foreign model, that is the subject. So for that we will use a foreign key, and it connects with the subject dot id. I think we defined the foreign key as for capital foreign and key this way. Okay. Okay. So the foreign key interact with the subject, that is a foreign for this chapter, and it must have some value. So it 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 cannot be blank because we have to show the relation with the subject. Subject can have multiple chapters. Chapter independently has no identity, so it must have subject as parent. Okay, so that's why the subject ID must have some value. So the nullable false ensures that. Then the chapter will have the relation with the quiz. So the chapter must will have multiple quizzes and the relationship. Uh, so we define the relation with the quiz. So chapter will have multiple quizzes. So we are defining the quiz model to relate, and then the similar backref we needed to fetch chapter from the quizzes. So it will backref the chapter, and legi must be true to not include the data if we don't need. Then we have the question model. Okay, the question model, initiate the question model with the db.model, and then the id will be same. Okay, then okay, we missed something for the quiz. Okay, we have missed the quiz model. Just create that model first. So class quiz db.model, and then start with the id. So id will be the same, the primary key. So you can copy and paste here. Then the quiz will have the date of quiz, that will be the date time type field. So date of quiz will be, the column will be of date time type, date time, and then the time duration, and that column uh, must have the type of integer. Okay, and you can add the nullable false here because it is needed, uh, like when the user will start the quiz, so we need the time duration to show at their dashboard. So the integer value then convert at the user dashboard side, like in this format mm. So we'll convert the seconds into the hour and minutes. Okay, the next is chapter id. Yeah, we need a foreign connection with the chapter. So we needed a chapter id column where the column will be of type integer, and the foreign key uh, will be chapter.id to interact with, and it must have the value. Okay, okay, is it right? Correct. Then the quiz have a relationship with question. So quiz have many questions, can have many questions. So questions, and the relationship is, so quiz will have multiple questions, and it will interact with question model to fetch those, and backref is, so question can get the you can get the quiz attribute with a question, like question dot quiz dot date of quiz, something like that. So that's why you have to provide the backref as quiz, and then lazy true because we don't want to load unnecessary. Okay, then we have to define the question model. So class question, initiate this model with the db dot model, and then question will also have the id. All the tables have the id. Then question have these fields. The first is question statement, question statement, question statement, and that column must have text type because we don't know how much, or we don't know exact the limit of the text. Okay, so we cannot uh, have the string type of. Okay, and it must have the value, or just leave it, no issue. Then we'll have the option 1 field, and that field must have the type of I guess string will be a good choice, and we can supply the character limit as 200. So I guess this is much for the option, and there must be have the value because we will need it to compare with the answer. Okay, and similarly we will have 4 option field, the 2, third, and the fourth, and then we will have correct option column, correct option column of type integer. So we can it will also be the false, and then we can provide the answer as 1, 2, 3, or 4, and then we can match like which option is correct. Okay, okay, then we have the quiz id. Yeah, the question must have relate with the quiz. So quiz id that relates with the quiz id, and this column will be having the type of integer, and it connects with the foreign key from quiz.id. Okay, and it must have the value, must. Okay, then at last question has not associated with any models, so leave it here. Next we have the score model. So the score model will have the id as the column will have the type of integer, and this is the primary key, so primary key is true. Okay, then we have total scored, and this column will have the type of integer because we have to store like 7 out of 10, 8 out of 10, something like that. Okay, it must have some values, and then we have timestamp. So timestamp, and this column will have the type of date time, and we don't want to fill the timestamp manually, we don't want to enter it, must have automatically set. Okay, so for that we use db functionality, db.func.current timestamp, that will set the time automatically. Okay, Cool. Then we have the user ID and quiz ID to connect with. So score will connect with quiz using the quiz ID, foreign key, so db.column. The type is integer for this column, and it will connect with quiz dot id, right? And it must have the quiz id value. Okay, so it will link the quiz with the score, and then we also need a link with user. So similarly, the type will be of integer, and then the foreign key will be user.id to connect with the user, and the nullable must be false. So it should not be null value, it must have some user id value, so we can show the relation with the user for this score. Okay, after that, yeah, we don't have any other relation. So we are done with creating the models. We have created the user model related to the added the relationship with the scores. Then we have created the subject model and add the relation with the chapter. Then we have the chapter relation with the quiz, and quiz has a relationship with the question, and question we have that is connecting with the quiz id using the foreign key quiz.id, and then um, the score that connects with quiz and user. Uh, so at the quiz, it connect with the quiz.id. So this quiz ID in the score will match with the ID in quiz. Okay. So some of the quiz record that will have the same ID, then it will connect with similarly with the user ID. So we are done with the creating models. Now next is initializing the database. So for doing that, so from app.models import the user subject chapter quiz question score, and then uh, we have creating the application here. This application we are calling and storing in application app, and then what we have to do, we have to create one CLI command to initialize our database. So the command will be db create, and that will handle by create db. Okay, create db, and for creating the db dot create. Okay, we need to import the db also now from the application. So db, and then we can run db.create all to initialize the db, and after initialization just print the database created. Okay, that will be good. And then okay, so we have initiated our like we have created a command for initiating our database. So run the command now, like, and how we'll do that. So there is a command flask, and with the flask you have to run the CLI command, that is the db create. So db create, and it is not working cause flask thinks the entry point will be the entry point is f.py, but in our case the entry point we have renamed as the run.py. So for that you have to give the value like flask fh run.py, and inside run.py we have a script, or we have a CLI command db.create to initializing our database. Now run this. Okay, we got some error. Total scored, and we have many errors, I guess. Okay, so the error start from line 1. Okay, 46 score model having some problem. So go to the models, total scored, and db.column db.integer. Okay, so it must be started with capital. Okay, that was the issue. Now initialize the database again using the flask --f and f is run.py. The script is run.py, and run the CLI command now. Okay, so it has created our database, and print database has created, and we can see, or uh, we can check this by seeing this file. So when we ran this command, it has created a folder, the instance, and inside instance, whatever file name we have given for creating the database, it has created with that name. So master.db we have given as name here, the database URI equals master.db, and it has created with the same name, right? And initially I have added this file in git ignore to ignore this file while pushing to the production coach. This is for local purpose, and this is a binary file, so you cannot view the content here. This is just the, it has the file, you cannot access, okay, directly. But we don't need to push this file to production because production data could be different. This is for the local, so you have to ignore this file uh, to push to the production deployment or GitHub. Okay, cool. And now after initializing our database, we will test the database by feeding some data in tables, and then we will query the data. Okay, so for testing that, we have to enter in the cell flask cell. Flask cell basically it's a Python based interactive cell, and it connects it connects with the application. So you can see the app is our application. You can interact with the application using the app, and our database connection also there. Okay, you see the file here, so it connects with the database. So for testing we will create a subject. Okay, so for doing that, from f import db, then from models we have to import subject, and then we will create a subject. So just create a math subject, and to create a subject record, you have to write this way. So the uh, you have to start with the object. So subject is the object, the model, and inside this you have to give the values. So the subject have fields name and description, and this is a primary key, so it will automatically get generated. Okay, so you have to just give the name and description, and yes, this is the relation only. We don't have to feed that. It will be created, the relation will be initiated when once we have the chapter, and chapter will have the subject id connect with this id. Okay, so you have to provide the name and description here. So the name is math, and then the description, um, in this subject we will learn math concepts. Okay, and enter it. Okay, yes, we have to give the equal, not the colon. Okay, so then we have the subject, and then we have to use a session. We have talked earlier, like db gives two functionality, the db.model to create the model, and then the db.session to interact with the database. So the db.session add, and we are adding this object, math subject object, that is type of subject, and that will translate to subject table, and then the table will uh, have these fields data. Okay, so we are adding. So once we run the add command, so it just create a snapshot. Okay, and then we have the commit command, and that saves the data. Okay, sorry, then it saves the data that we have added to the database. Okay, so it's similar to like github git commands, as we have discussed in git section, where we add the code and then we commit the code. So when we commit the code, so it just create a snapshot of the changes. So here similarly, when we use the add, so basically it is creating a snapshot of your record, and when we commit, so it just save that record inside the table. Okay, now we have created a record in subject table. Now we will query that record and see if it is working or not, or if it has been recorded or not. So how to query that? So for querying, use subject dot query dot all. So I have been fetching all the subjects. Okay, so basically the variable must be have subjects, and then we will, so it will fetch the all the subjects in array, and then we have to find the first record. So subjects and 0 will give the first. Okay, so we have the object here. Okay, and with the object, now we will see how we can list the fields. Okay, so we don't need to write the queries, just subject dot name, and we can see the name that we have given. And if you want to check the description, we have the description also. So the test has been completed. Our database is working perfectly. We have created the models, then we with the models we can create the record. We can add the record using the the add command, and then we can commit into the database, and then we can query the database. It's working fine. Okay, now close the cell. So we have tested our database successfully by feeding some data into subject and querying it. Okay, now just push the code in Git. So for that, as you have learned, add all the files and check with the status, git status. So we have modified one file, git ignore, where we have added the instance folder because we don't want to push. Then we have modified our init.py file where we have initiated our database and connect the database with the application. Then we have created a new file app.models.py where we have listed all the models for our database. Then we have modified our routes .py file where we have created a CLI command to initialize our database. So we have done with these changes and we have staged all the changes. Now we will commit so we can push. So with the commit, you have to give a message. So what you have done, you have uh, set up the database and created models. Okay, so you have named that snapshot. Now you can push these changes. So for pushing, git push remote name origin and which branch you want to push, the change you want to push in main branch in remote repository. So do that. So the changes has been pushed and you can verify the changes by going to GitHub URL and check a repository. So here is a repository and you have to click here. 3 commits are there. The last commit that you just created and you can see what are the changes you have done by clicking on the commit. So just click on the commit and you can see the recent history that you have just done. Okay, so add the instance here and init.py and the models.py and routes.py. Okay, this way you also check the GitHub. Okay, we are done here. That's it for this video. You have created your SQLite database. You have created the models for your Quizmaster application, all the models. And in the next video, we will create the user registration and login. See you next time.